Last time we left off with the heads-up display displaying some cool elements, but the thing is this whole thing is pretty bulky and the connections are only temporary. And I mean, imagine this thing being on an actual plane. It'd just be the wires would come off in flight and it's just too big, it's just a big mess. So ideally I gotta shrink it down and make it a lot more durable for use in aerial combat eventually. So what I did was I bought like a PCB or proto board, I think they're called. It's pretty much a blank canvas for soldering connections and making them a lot more permanent. And instead of soldering the components directly to the board, I used a lot of sockets because that way if something was messed up, I could swap out the components instead of having to desolder the whole thing. And this was a great idea because I messed up the first board and I could just take out all the components and then start fresh on another board. The sockets are also pretty good because the space between the sockets could be used for actually hiding the wiring. So now came soldering. It was a slow process because although it's possible to remove a solder joint, I'd rather not do that and get everything messy, and plus it just takes time. So here was my process. First, I took note of all the connections from the breadboard and made a schematic for the circuit. To make sure I got everything right the first try, I created a spreadsheet where I organized which sections would be connected to what pins. Some quick points on that. I decided that I would integrate the camera into this HUD circuit so that I wouldn't have to have a separate battery and setup for the camera. After that, I did a dry fit to see if there would be enough space for everything I planned out. Next, I actually started to solder the things to the board. And my process went like this. First, I would double check my schematic and spreadsheet to make sure that the wire I was working on was indeed connected to the right places. Then I would solder that wire down. After that, I would connect the wire to the actual pins that they were supposed to be connected to. And as a last check, I would ensure that there was a connection between the parts that needed a connection. Basically, it's a constant checking process so that if something was wrong, I knew exactly what it was. Of course, that didn't mean there weren't any problems. A big problem ended up surfacing pretty late in the whole process. I had already connected all the sensors and screen, and it was all working for a while at least. And then when I connected the camera and when I tried testing it, the camera just wouldn't work. So that was pretty confusing. I checked the voltages the Nano was putting out and found that the 5-volt output was barely doing 3 volts. And even the 3.3 volt output was bordering around 2.8 or 3 volts, something was up. I was really thankful I used those sockets because I just uprooted all the parts and then put them back into the breadboard and connected them back in a configuration that worked previously. I then powered the Arduino with the built-in USB connection and surprisingly everything worked fine. Then I tried the battery power and all the sensors lit up, but the OLED or the display didn't. I noticed that the lights on the Arduino were a lot dimmer when powered by a battery than USB, so I thought maybe the battery was just low. I charged the battery up and then I tried it again, and this time the lights were a lot brighter, but still no OLED. I checked the voltages that the Arduino was outputting and they were still low somehow. At this point, it looked like the USB connection was the most reliable way to power the Nano, so I checked to see how many volts the USB was actually handling, and I found it was 5 volts. After that, I found an old mini USB connector, and I thought I could just wire the battery up to this connector and then use it to power the Nano. As I was doing this, I had a better idea. Instead of using a separate battery to power the heads-up display, I could just take the power from the main battery that powers the motor and do the same thing. The HUD doesn't take too much energy, so this should be fine because it's not going to be sacrificing too much power. The way it works now is like this. The main battery connects to the electronic speed control, or the ESC. The ESC is what takes power from the battery and safely supplies it to the motor. However, the ESC also supplies power to the receiver with this wire right here. The receiver uses the power from the ESC to power the servos and anything else you've got connected to it. So in this case, a heads-up display. The receiver outputs 5.3 volts, which is more than 5 volts, but it worked fine when I tried it, so I'm just going to roll with it and see what happens. So good news, problem solved for now. The HUD is a lot smaller, and I actually managed to make it more integrated. We'll see what happens in the future because I still haven't connected the camera to it, and maybe it'll go wrong again, but for now I'm pretty happy, and yeah, we'll see what happens. Code, I haven't really changed much in terms of code. If you want to see what it's like right now, just check my GitHub. I'll probably make some small changes in between videos, just in terms of making it look a lot better and making the layout a lot more appealing. But other than that, I think most of the HUD code is done, for now at least. Okay, here's a really exciting part, an actual demo of what it's going to look like. So right now, it just turned on and it's calibrating. That's why we have this weird screen. But once it's done calibrating, there you go. You see a bit of a double image because the glass isn't that good, so I'll probably get a better glass. And it's a bit dim, so I'll figure something out for that. But in general, really cool stuff.